Hello everyone and welcome back to FE exam preparation for mechanical engineers. In today's statics video we are going to be doing a frames practice problem. So in today's problem we are asked to determine the support reaction forces at point D. So we are given the following frames A, C, D, and frame B, C. Each frame is connected via point C, or pin C rather, and is supported by pins B and D. Okay, so I'm first going to define a coordinate system for use in this problem. So just standard Cartesian coordinates with a positive counterclockwise moment. Okay, so the first step that I like to do is to break each frame into its own free body diagram. So we are going to do a free body diagram for frame 1 and frame 2. So frame 1 will be BC, and it's going to look like an L structure. We're going to have the pin B here and pin C over here. So because they are pins, they are both going to have a Y and X reaction force. And we always assume tension. And that is it. So now we can move on to frame 2, which is ACD. It's going to look like this C structure here. Point D, point C, and then point A. Okay, so we have that 48 kilonewton load at point A. We have pin C again. So when we have a pin that is shared between two structures, we must use Newton's third law, which states that each force has an equal but opposite reaction force. So all we have to do to handle that is just point our forces in the opposite direction, like so. Equal but opposite. And then we are going to have our pin reaction forces at point D. Okay, so the next step would be to draw the dimensions on the free body diagram, but I already did that for us, so we're going to move on here. So all I've added are the dimensions from the problem. So the next step would be to do the sum of the forces and sum of the moments. You're always going to want to begin by choosing the frame which has the loading on it. So if either frame had some sort of loading on it, you could do either frame, but because frame 2 has the 48 kilonewton loading on it, we are going to begin with that frame. So frame 2. So we are going to take a sum of the forces in the x direction and set that equal to 0. So that is going to be dx minus cx is equal to 0. Therefore, dx is equal to cx. Now if we sum forces in the y direction and set them equal to 0, we will get that dy minus cy minus 48 kilonewtons is equal to 0. Okay, great. So this next step, when it comes to summing moments, you're always going to want to pick a point that 1 has reaction forces and 2 is not the shared point of interest between each frame. So you'd never pick a point like point C. So that is why we are picking point D. It has reaction forces, but it is not shared between the frames. Point C is ultimately what we are going to use to combine the frames together mathematically and solve for the reaction forces of each frame. Okay, so summing the moments about point D to be equal to 0, and you'll see what I mean as we work out the math. We are going to get that CY creates a positive moment, and it is 8 meters away. CX also creates a positive moment, and it has a 5 meters lever arm. And the 48 kilonewton load also creates a positive moment about point D, and it has a 4 meter lever arm. Okay, so just a review of the lever arms here. For CY, right, the perpendicular distance to force CY is 8 meters. The perpendicular distance to force CX is this 5 meters, and the perpendicular distance to force the 48 kilonewton force is this 4 meters. Okay, so let's leave that be for now. Let's work on frame 1. So frame 1, you're going to do the exact same steps. Sum of the forces in the x is equal to 0. So that's going to yield bx plus cx is equal to 0. Sum forces in the y is equal to 0. So that's going to yield by plus cy is equal to 0. And then we are going to sum moments, not about point C, but about point B, and set them equal to 0. This is going to yield a negative moment caused by CY, and its lever arm is 8 meters, and a positive moment caused by CX, and its lever arm is 3 meters. Okay, so now you can sort of see where that overlap I was talking about is coming from. We have this equation here, right, with just CX and CY, and we also have this equation here with just CX and CY. So we're going to use the fact that we have those two equations and they have two unknowns, so we have a system of equations that we can solve for for the variables and then plug them in to get our what we desire, which is the reaction forces at point D. Okay, so moving from there, I simply just solved for CX here. So all I did was I added 8CY to the other side and then divided by this 3 here. Okay, we have CX. We can go ahead and plug that in to this equation up here, which I'll call 1. In this equation, I will call 2. 2. So plugging this into 1, let's see what happens. We have 8CY plus 5 times 8CY over 3 plus, do that 48 times 4 real quick, 192 kilonewtons, kilonewton times meters, is equal to 0. Okay, so just rewriting some things and simplifying. 5 times 8 is 40. And then 40 divided by 3 is 13.33, repeating. So that's 13.33 CY plus 192 kilonewton times meter. Okay, so we can now go ahead and just solve simply for CY. So take the 8 and add it to the 13.33, right? And then take 192 divided by that number, and it'll come out to be negative, right? Because we have to subtract that 192 over. So this comes out to be roughly negative 9 kilonewtons. Okay, cool. So then therefore we can get CX, right? Just plugging this into the CX equation, right? And that will give us 8 times 9 divided by 3 is 24, so negative 24 kilonewtons. Right? Okay. And now, because we're interested in the reaction forces at point D, our lives are made very simple. If you look at this equation up here, right, we have dx is equal to cx, and then dy minus cy minus 48 is equal to 0. So let's use those and solve. So dx is simply negative 24 kilonewtons, and then dy is equal to 48 kilonewtons plus cy is equal to 48 kilonewtons plus a negative 9. So this is going to be minus 9 kilonewtons. And that is simply equal to 39 kilonewtons. This is our answer that we would plug in on the FE exam. So the hardest part about this problem was probably recognizing that we must use Newton's third law on our free body diagram here, to split up the frames into separate free body diagrams, and then to know that we want to relate each frame using point C and summing moments about a point that is not point C. Okay, well, if this problem helped you in your studies, please drop a like and subscribe to the video. We are greatly appreciating of that. And let us know in the comments below what content you guys would like to see, or what kinds of problems. If you'd like to do a different sort of problem that we've already done before to see more examples, please just let us know. And we will see you on the next video. Thanks for watching.